Good evening. Today in class we did book work on 7.2. If that's not finished, then that's your homework as well as watching this video and filling in our notes and our examples. So tonight we're going to learn 7.3 special right triangles. Well, a right triangle we know is a triangle that has one of the angles a right angle. So what would a 45, 45, 90 be? So let me draw you a picture. Let's try again. Come on, little pin. Alright, so here's my picture. I have a triangle with a 90-degree angle, and then I have my two other angles, 45 and 45. Hence, 45, 45, 90 triangle theorem. So the hypotenuse is going to be the side across from the biggest angle. Well, 90 is the biggest, so this is the hypotenuse. We'll abbreviate it there. And then the other two are the legs. Whenever we have a 45, 45, 90, I'm going to tell you that the sides are proportional. Leg, leg, so 1 to 1 to 1 square root of 2, or just to the square root of 2, because 1 times the square root of 2 is the square root of 2. So the hypotenuse would equal, hypotenuse is going to equal the length of whatever the leg is. So if the leg over here was 5 and this was 5, we would write 5 to 5 to 5 square root of 2. That's kind of why I put that 1 there, just to know you could plug in for whatever the leg length is. So hypotenuse equals leg times the square root of 2. And remember, you can pause at any time if you need to write something down at home. So let's look at this example. Find the value of each variable. If necessary, leave your answers in simplest radical form. So make sure that's why we were practicing our radicals last week. So we have a 45, 45, 90. So we know this theorem's going to work. So, and it says solve, find each variable. So I know that the hypotenuse, or x, equals leg times the radical of 2. So a leg is equal to 5 radical 6, and the hypotenuse equals leg times radical 2. So x would equal, because x is the hypotenuse, 5 radical 6 times the radical of 2. Now we need to multiply those out. So the radical of 6 times the radical of 2, we can combine those. I would get 5 radical 12. Let me slim down my pen here so I can get some more space. Thank you. Alright, so 5 radical 12. Am I okay with that answer? Well, no, because I know I can break down 12. I could do 5 times, well, I could pull out of 12 a 4 and a 3. So that would be 5 times 2 radical 3. And then I could do 5 times 2, which is 10. Radical 3, and I think that I'm happy with that answer. So my hypotenuse, or my x, is equal to 10 radical 3. I want you to try B on your own and solve for Z or V. Right away we know V because V is a leg, and this is a 45, 45, 90, so we can right away say that V is 8. So solve for Z the same way we solve for A, and we'll check that one tomorrow. Okay, on example 2, we're doing the same thing using a 45, 45, 90 theorem, but now it says find the variable in radical form. Well, that's the same. The difference is that we're finding the length. So it gives us the hypotenuse. Well, this is a 45, 45, 90, so I know the two legs are the same, so both legs equal x. So I could write this as 22, the hypotenuse, equals a leg is x, times radical 2. So we kind of have to think backwards in radicals. So, well, I just want x by itself, so I can divide both sides by radical 2. Now I have x equals 22 over radical 2. Am I okay with that? Well, of course not, because I don't want a radical on the bottom, so let's multiply that by the radical of 2, the radical of 2, radical of 2 times radical of 2 is the radical of 4, or the square root of 4. Square root of 4 is 2. And then on the top, I would have 22 radical 2. And I'm almost done. Am I happy with that? Almost, because the radical's on top, but 22 divided by 2 is 11 radical 2. So x, the leg of the hypotenuse, is going to equal 11 radical 2. B is going to do the same thing. I have the hypotenuse here. I know my legs are the same, so both of those are y, and you're going to solve that one at home in simplest radical form, and we will check it tomorrow. Example 3. The distance from one corner to the opposite corner of a square playground is 96 feet. Find the length of each of the playground. Find the length of each side of the playground in simplest radical form to the nearest whole number. Draw and label a picture first. So let's start with drawing our picture. 96 feet. Okay, so we got 96 feet from one corner to the other. And then we have the playground. Here's our triangle. We know this is a square, so we know we have a 45, 45, 90. There's my two x's. Oh no, hold on. From each side, so we have a square, so we know we have a 90-degree angle here. But we don't know, it might be a 45, 45, and you can use the hypotenuse leg, because I believe if we cut that diagonal straight across, that's going to be 45, 45. So it's up to you. You can either use Pythagorean theorem or the hypotenuse leg, just so we can review. Pythagorean theorem, I'm going to use that. So I would know a squared or x squared plus b squared or x squared equals c squared. 96 squared. And then I would do two of these guys. 2x squared equals 96 squared. Then I would get the answer to 96 squared and divide it by 2, and then I would use the square root to find x. So I either want you to use the hypotenuse theorem, 45, 45, 90, or the Pythagorean theorem, and I want you to solve for x. And our answer is going to be in feet, so we'll check that tomorrow. Alright, now let's talk about the 30, 60, 90 theorem. So if you have 30, 60, 90 theorem, similar to the 45, 45, 90, you're going to have a triangle with a 90-degree angle, so it's a right triangle. You have one of the angles at 60 and one at 30, and this could be this one's 60 and this one's 30. It's fine as long as you have 90, 30, 60. Okay, so the side that's across from the 30 is going to be the shortest side. So we're going to call this side the shortest leg, short leg. And then the side that's across from the biggest, the 90, is obviously the hypotenuse. And then this other guy is a leg, and in comparison to the short leg, this is going to be our long leg, because 60 is bigger than 30. So across from the 60-degree angle will be the long leg of the two legs. So for this, we're going to say our sides are proportional to the ratio 1 radical 3, 2, with 2 being the hypotenuse. So hypotenuse would equal 2 times the short leg, and the long leg would equal radical 3 times the short leg. So this one has a couple more details, but once we practice, I think you'll get the hang of it. So let's go down and give example 4 a try. Find the value of each variable. If necessary, leave your answer in simplest radical form. Find the lengths of the legs. So I know that hypotenuse, because I've given 10, that's the only thing I've given. I have a 30, 60, 90 triangle. I know that short, look up here, times 2, the short leg, so I'll just do short L, times 2 equals the hypotenuse. Okay, well the hypotenuse is 10, equal to 2 times the short leg. Well, what's the short leg? Well, we don't know, so let's leave it as the word short for now. Well, short now equals, short times 2 equals 10, or x times 2 equals 10. So short divided by 2 would just be short equals 10 divided by 2, so short is 5. That works because short could be our x. X times 2 is 10. What times 2 is 10? 5. So now we know short is 5. Well, now we need to find the long. Well, a long leg, look up top there, long leg says long leg equals radical 3 times the short leg. And what's the short leg? We just found the short to be 5. So then we just multiply those together, so we get 5 radical 3. So if you wanted the lengths of the legs, the long leg across from 60, the bigger one, M, it's going to be 5 radical 3, and then the K is going to be 5, and that works. So it says it has to be in form 1 radical 3, and then 2, and we have that because we would have 5 radical 3, and then 10. And so the 10, it doubles from there. So I want you to look over this, practice it, watch it a couple times if you need to, and I want you to try to do the same thing for B. All right, here we go. So we have our example problem 5, letter A, and it wants us to find the length of the leg, and we're going to use our new formula here. So let's try letter A. Number 5, we know that the hypotenuse equals 2 short, so we'll do just like we did last time. Equals 2 short. And my short side is going to be across from the shortest angle, which is this one. So I know the short side is radical 6. So the hypotenuse equals 2 radical 6. And then I know that the long, or the P, equals, and I can go ahead and put 2 radical 6 here for W. The long equals radical 3 times the short, and the short is radical 6. Radical 6 times radical 3 is the square root of 18. And then I have square root of 18. I can split that up into 9 and 2. I'm going to let you finish this one, as well as do what I've done and finish in simple radical form for B. We'll check that tomorrow. Alright, find the value of each variable if necessary, simple radical form. Alright, so this one we have 2 triangles. Our first triangle is a 45, 45, 90 on this side. This one is a 90 here, a 60 there, and a 30 here. So on the left triangle over here, we can use our 30, 60, 90 rules, and the right side here we can use our 45, 45, 90 rules. So as far as, let's start with, what do we know? We know this 5 here, so let's start with that. So I have one leg, sorry about that. I have one leg, and the leg I know, come on, is 5. So that tells me that I can use that leg with my 45, 45, 90 to solve. So if this leg is 5, then the other leg is also 5, because I'm working, come on, at 45, 45, 90, I'm working at 1, 1, 1 radical 2. So I have 5, 5, and then leg radical 2. So that'll be 5 radical 2. Now that I have 5 here for this x, I can look and say, okay, well the 60 is across from that 5, so I know that the long side is equal to 5. So if I wanted to solve that, I know long equals radical 3 times the short, and I know that the long is 5. So I'll let you go ahead and go from there so that you can find the short. Once you find the short, you'll find the hypotenuse with your rules. Please bring your answers for W and Z to class tomorrow. And then as far as B goes, remember we have our formula, 4 sides, so we have n minus 2 times 180. This is all the way back, I think, from chapter 3. So n minus 2, I have 4 sides, so 4 minus 2 is 2. 2 times 180 is 360. So this figure is going to have 360 degrees. So my missing piece here, I could do 360 minus 90 minus 90 minus 60 to find that. There's a couple different ways to do this. I think the best way is going to be to split this into a rectangle and a triangle and go from there. And this is going to be 30, and this is going to be, if I chop it off at a complete L, 90. Let's make sure that makes sense. 90 plus 30 is 120. 120 plus 60 is 180. 180 plus 90 plus 90 is 360. So my angle measurements are accurate, so I can use facts from a rectangle and then facts from a 60, 30, 90 to help me solve for these. So also bring your answers for side A and side B to class tomorrow. So that's the homework, is just finishing the notes and the examples, and we'll do the book work in class. Have a good night.